Significant figures. We are still on significant figures. We already dealt with concept of significant figures. We already talked about identifying significant figures and uncertain digit. And now we will be working with significant figures. After that, we will look at rounding off of numbers and then standard form and scientific notation before we actually get into the formulae used for physics. How to use concept of significant figures in calculation. There are two rules, one for addition and subtraction and the other for multiplication and division. Now for addition and subtraction, the rule is that there cannot be a significant figure in a column that is to the right of a column or position already containing an uncertain digit. Cannot be a significant figure in a column that is to the right of a column or position already containing an uncertain digit. So let us say you were given these numbers to add without a calculator. You write them down like this: 25.7 kilogram. It has 3 significant figures and 7 is the uncertain digit. This now number has 4 significant figures and 6 is the uncertain digit. This one has 2 significant figures and 5 is the uncertain digit. This one has 6 significant figures and that 0 is the uncertain digit. And this one has 3 significant figures and this 5 here is the uncertain digit. And you come up with this answer, 2,846.301. Now, if you leave it like that, CXC will deduct a mark because you have too many significant figures. You have to round off. Now, this is what you will do. If you put these in columns, as I said over here, and you draw a line straight down, a vertical line, beginning at the far left and moving to the right, the thousands position, as you could see, has no uncertain digit. You can also see that in the hundreds position, there is no uncertain digit. However, when you come to the tens position, if you draw that line again, you will notice that there is one uncertain digit there, and that is this 5. So what this rule is saying is that you have to round off at this place value, wherever you meet this first uncertain digit. So we have to round off at this 4. Now 2,848.301 rounded off to the nearest tens, because this is the tens position. 2,846, is it closer to 2,840 or 2,850? Obviously, it's closer to 2,850. So we round it off as 2,850 kilogram, and we have 3 significant figures. Now, since we round off at the tens position, the answer really means plus or minus half of that position, which is 5. So if you add 5 to 2,850, or you take away 5 from it, the range is 2,845 to 2,855. But normally, this is the way you would write your answer in physics: 2,850 plus or minus 5. Now, if you don't have the time nor the inclination to set down the numbers as you see on the far left, and you want to do it quickly on your calculator, consider each number to see which one has an uncertain digit in the highest position, then round off at that position. If you look at these numbers over here, the uncertain digit in the highest position is this 5, and it is in the tens position. So even if you use your calculator to do this, when you write down your answer, you know you have to round off at the tens position, and then you round off as you see here. Now that's for addition. Now you do the same thing for subtraction. Your answer cannot contain a significant figure in a column that is to the right of a column or position already containing an uncertain digit. So let us say you had to subtract from 2,400, you had to subtract 0.245 meters. If you look at the first number up here, you have two significant figures and 4 is the uncertain digit. Two significant figure and 4 is the uncertain digit, like that. This next number here, you have three significant figures and 5 is the uncertain digit. Now, when you subtract this below number from the top one, you get 2,399.755. If you leave it like that, CSEC will deduct a mark because you have too many significant figures. The same rule applies. If you draw a line coming down from the far left, you notice that you have not encountered any uncertain digit in the thousands position. If you draw a line in the hundreds position, you have encountered an uncertain digit at this 4. So you have to round off in the hundreds position. So you have to round off here where that 3 is. So 2,399.755 rounded off to the nearest hundreds. 2,399, is it closer to 2,300 or to 2,400? And of course, it is closer to 2,400, so you round it off to 2,400. But bear in mind, you are rounding off at the hundreds position, which means that your answer is really 50 more or 50 less, half of the hundreds position. So 2,400 plus or minus 50 meters, that will be the correct answer. And the range is 50 more to 50 less of that. Now, this is what you use for addition and subtraction. If you notice, we subtracted this number, 0.245, from 2,400, and our answer is still 2,400. And that is because your margin of error in the first number, which is 100 or 50 plus and 50 minus, is much greater than this 0.245, and therefore you get the same answer. You may recall when we were dealing with video 1 and we're talking about a mosquito and your mass. So if you were to add 65.7 kilograms plus 0.0035 kilogram, you still end up with 65.7. Now for multiplication and division, the rule is even easier. It says that your answer cannot have more significant figures than the factor with the least number of significant figures. If you are multiplying, let's say, 3 numbers, and one of them has 1 significant figure, one has 4, and one has 2, then whatever your answer is, you would have to round off to 1 significant figure. Your answer cannot have more significant figure than the factor with the least significant figures. So if we look at this example, 3.4 meters multiplied by 1.234 meters multiplied by 23.5 meters, if you put that in a calculator, you would get this. If you leave it like that, you will lose a mark at CSEC. We have to apply the rules for significant figure as it relates to multiplication and division. The first number has 2 significant figure. This one has 2 significant figure. The second number, this one has 4 significant figures. And the third number has 3 significant figures, 3. What is the least number of significant figures in these numbers? And the answer is 2. So our answer can only have 2 significant figures. So we count from the left going to the right. We count the 9 as 1. We count the 8 as the second one, and we stop. So we have to round off at the ones position where this 8 is. So you're rounding off 98.5966 to the nearest ones, and your answer is 99 cubic meters. Since we are rounding off at the ones position, then it is 0.5 more or 0.5 less. So we would normally write our answer as 99 plus or minus 0.5 cubic meters. If we want a range, it is 98.5 to 99.5. Now that's for multiplication. The same rule applies for division. If you're dividing two numbers, one has one significant figure and one has four significant figures, your answer will contain only one significant figure. So let us divide 500 cubic meters by 1.234
square meters.
Our answer will be in meters. But what will be the number here? Now, in the calculator that I am using on this computer, this is the number that actually comes up. However, let's apply the rules. This first number here, 500, has one significant figure. This number here has four significant figures. So the question is, what is the least number of significant figures in these two numbers? And the answer is 1, which means that your answer can only have one significant figure. So if we count from the left going to the right, we count at 4, that will be our first significant figure. And since we only are allowed one significant figure, we will have to round off at that hundredths position where the 4 is. So 405 to the nearest 100. Is it closer to 400 or to 500? Obviously, it's closer to 400, so you round off your answer to 400. But since we are rounding off at the hundredths position, our uncertainty will be 50 more or 50 less, half of that position. So our answer is truly 400 plus or minus 50 meter. But we can also state it as 350 to 450 meters. Now let's apply those rules in a few examples. Example 1A, we have a rectangular floor as seen here. It has a length of 12 meters, two significant figure, and a width of 7 meters, one significant figure. You are asked to find the perimeter, which means that we have to add. So perimeter is equal to twice the length plus the width. Now this 2 here, even though it's one significant figure, it is not a measured quantity. While we are multiplying by 2, we will not take it into account when we are dealing with significant figures. So we add 12 and 7, we get 19, we multiply that by 2, and we get 38. Notice that the uncertain digit in this 12 is at the ones position, the uncertain digit in the 7 is at the ones position, so this 38 is perfectly fine. That is if you're asked to find the perimeter. Now, if you are asked to find the area, we have a somewhat different situation because now we will have to multiply those two numbers. Area is equal to length times width. So we multiply 12 by 7 and we get 84. But recall we said that for multiplication and division, your answer cannot have more significant figures than the factor with the least significant figure. So this has two significant figure, this has 1, so our answer can only have one significant figure. 84 has two significant figures. We have to round off at the 8. We are always rounding off from the left to the right. So we have to round off at the 8, which is in the tens position. 84 is closer to which tens? 80 or 90? 80. And since it is the tens position, it will be half of that position, more or less. So our answer is 80 plus or minus 5 square meters. Now you could have written it as 80 square meter, correct to one significant figure. Now, if you want your answer to be more precise, maybe you should have said that the width is 7.0 meter instead of the 7. Now, in that case, this will now have two significant figures. The 12 will have two significant figures. And so we are now allowed to use this 84, which has two significant figures. And since the uncertain digit is at the ones position, which where the 4 is, then we will divide that 1 by 2 and we will get 0.5 more or 0.5 less. So our answer to this is 84 plus or minus 0.5 square meter. Now, this answer over here on the right is more precise than this one over here. It's spread out a little more. This is spread out by 10 meters, 5 more and 5 less. This one is spread out by only 1 meter, 0.5 more and 0.5 less. That's example 1. Example 2, a lady has a weight of 591.0 Newton. Notice that is 4 significant figure. She wears stiletto high heel shoes with each heel measuring 5.0 millimeter by 8.1 millimeter. These two numbers here have 2 significant figures each. As she walks along a wooden floor, she temporarily rests all her weight on one heel. At this time, how much pressure does she exert on the floor? All right, we have two formulas to calculate pressure. This one here, which is used to calculate pressure in a fluid, which is not the formula that we are required to use here. The other formula is pressure is equal to force over area, or weight over area, and this is the one that we would have to use. If you need to do a calculation within a question and then use that answer further down in the question, you would keep more than the required significant figures, and then when you come to the end, you round off. So, let's see. We know that the force or the weight is 591.0 newtons. We know that the area, if we multiply 5.0 by 8.1, we will get 40.5 square millimeters. And if we convert square millimeters to square meter by dividing by a million, this is the answer we will get, because this formula, pressure in pascals, is equal to force in newtons divided by area in square meters. So when we divide that, we get this answer. Now, obviously, we have a little problem here because we have 4 significant figure in the first number and we have 2 in the other 2, but our answer has 1, 2, 3, 4, 5, 6, 7, 8 significant figures. Again, if you do that, CXC will deduct a mark because you have too many significant figures. So you have to round this off to 2 significant figures. So you count 1, you count 2, and you round off at that thousands position. And so you get 25,000 pascals, correct to 2 significant figures, or you could write it as 25,000 plus or minus 500. You can further shorten the answer to 25 kilopascals. And now you could actually see just the 2 significant figures. Third example, a ball of mass 200.0 gram, note that has 4 significant figures, was thrown in such a way that it has 22.5 joules, 3 significant figure, of kinetic energy. What was its velocity? Well, we know that the mass is so many grams, so we need to carry it to kilograms by dividing by 1,000. The kinetic energy, we are told, is this, and we want to find the velocity. The formula we have for calculating kinetic energy is EK, that's kinetic energy, is equal to half times the mass times the velocity. And the mass must be in kilograms. Now, if we change the subject of this formula and make V the subject of the formula, it now becomes V is equal to the square root of 2ek over m. We substitute those numbers in there, find the square root, and we get exactly 15 meters per second. But we have a little problem. Now, most times when you do that calculation, you get many more digits than you need. In this case, we are short of digits. Look at this one. It is 4 significant figures. This one, it is 3 significant figures. So we need 3 significant figures. We only have 2. 3 significant figures are required. So you just add a 0.0 to it. Now you do have 3 significant figures. And since this is our uncertain digit, which is the 1/10, half of the 1/10 would be 0.05. And so our answer is 15.0 plus or minus 0.05 meters per second. Or you could say 15.0 meters per second correct to 3 significant figures. Finally, in the last example, we'll be looking at the use of significant figures in these calculations. It says, in finding the latent heat of fusion of a substance R, a student used an immersion electric heater that draws a current of 0.25 amp that has two significant figures at a potential difference of 240.0 that has four significant figures volts. The heater was turned on until R begins to melt. With the heater still on, a stopwatch was turned on for 3.0 minutes, two significant figures, after which both the heater and stopwatch were turned off. The mass of R melted during the 3.0 minute was 54.0 gram, three significant figure. Calculate the latent heat of fusion R, assuming no heat loss. Let's look at these numbers again. We are going to do multiplication and division. So the rule we will apply is your answer cannot have more significant figure than the factor with the least significant figures. So you have two significant figures here, 4 here, 2 here, and 3 here. The factor with the least significant figure, well, it could be that 3.0 minute here or that 0.25 amp there. In any case, it is two significant figures. So whatever we do, our answer cannot have more than two significant figures. Neither should it have less. We get that the current is 0.25 amp. The voltage is that. The time is 3.0 minute, but that formula could only take seconds. So we have to carry it to seconds. The mass is 54.0 gram, which we need to carry to kilograms. We want to find the latent heat of fusion. There is a formula that says latent heat of fusion is equal to PT over M. P, of course, is the power in watt. T is the time in seconds. M is the mass in kilograms. But we don't know the power in watts. However, we do know that P is equal to VI. And we know V and we know I. So where P is in this formula, we take it out and put in VI. Now, LF, of course, is equal to V times I times T divided by M. And when you do that, the voltage multiplied by the current, multiplied by the time, divide by the mass, and you get exactly 200,000 joules per kilogram. Now, this has only one significant figure. The actual number from the calculator is 200,000, but we need two significant figures. State it like this, and since we are rounding off at this position, we take half of the 10,000 position, which is 5,000, and we list it here as plus or minus 5,000. That way, if you double this, you can know exactly where the uncertain digit is. It's in the 10,000 position, which is here. Or you can shift it to standard form, scientific notation, 2.0 times 10 to the fifth joules per kilogram. But we need two significant figures. We looked already at concept of significant figures in one video. We looked at identifying significant figures and uncertain digits. And we just looked at working with significant figures. Next, we will talk about rounding off numbers and then standard form, better known as, or sometimes known as scientific notation. As soon as you read the numbers in a question, you need to start thinking in terms of how many significant figures. And that brings us to the end of this video.